170 bison are pulling carbon from the sky. Not machines, not satellites. Bison. I'm Dr. Raymond Finch. I've spent decades watching ecosystems recover, and I have never seen a grazing herd rewrite atmospheric chemistry at this scale. 54,000 extra tons of CO2 a year, locked into mountain grassland because a herd found its old ground again. That transformation is what we're here to document. The Tsarku Mountains hold a particular kind of silence. Not the silence of wilderness, the silence of absence. No hoofbeats in the wet grass, no compression in the soil, nothing heavy enough to matter for longer than any shepherd alive can name. The grassland just sat there, year after year, tall, unbroken, ungrazed by anything with real weight behind it. The plants grew and collapsed on themselves. The soil beneath them slowly sealed over, like a wound closing the wrong way. Then, rewilding Europe brought the animal back. Each individual carries roughly of bone and muscle, enough to reshape the ground it walks across, crack soil crusts, press seeds into earth, and open channels for water the mountain had forgotten how to move. The herd now stands at 170 animals across roughly 20 square miles of mountain range. That is not a population, that is a system switching back on. One animal at a time, on ground that had been waiting without knowing it was waiting. And then the 2024 analysis landed. It put the carbon sequestered by that grazing herd, not by a machine, not by a government contract, at roughly 54,000 extra tons of CO2 pulled from the atmosphere each year. Let that sit in physical terms. That is what 12,000 combustion engine cars emit in the same period, absorbed by 170 animals walking their old ground. Every ton of that carbon was sequestered without a single euro spent on soil chemistry. The herd does it by grazing, by moving, by pressing their weight into hillsides that had gone soft and impermeable for a century. Rewilding Europe's field coordinator on the Tsarku project, she documented the first confirmed calf born on Romanian mountain soil in over a century. In her field notes, she had written that she expected 2, possibly 3 breeding seasons before any natural recruitment took hold. The calf arrived in the first season. She crossed out those pages and started again. A breeding timeline that should have taken 3 seasons collapsed into 1. The mountain did not need the schedule she had written. The animal already knew the ground. And the ground apparently already knew the animal. This is the part that made me stop and reread the field notes. What no model had predicted was the speed, not just of calving, but of the grassland response beneath the herd. Within 2 years of consistent grazing pressure, soil carbon measurements in grazed plots diverged sharply from ungrazed controls on the same slope, at the same elevation, under identical rainfall. The grazed plots showed measurable carbon gain. The ungrazed controls, just meters away, showed none. Same mountain, same rain, same altitude. One variable: whether something heavy had walked there. In the next part, we go back to before any of this was possible, to the decades when the European bison existed only in zoos, and a handful of scientists kept paper records of 12 surviving bloodlines, certain they were watching the last chapter of something ancient close for good. 12 captive survivors. That was everything left alive on Earth by 1927. 12 individuals in zoo pens across Europe, the entire species reduced to a handful of stud books and paper records kept by people who suspected they were witnessing a final chapter. Walk the Tsarku grasslands today, and the view deceives you completely. Green slopes, open sky, the look of something wild and intact. You would not see the damage unless you knelt down and pressed your hand into the earth. The southern Carpathians lost their last wild European bison in 1927. Within a generation, the grasslands those animals once cropped and turned began converting to rank monoculture. Tall grasses senescing, collapsing, building thatch so thick it smothered everything beneath it. The geography of that collapse is worth reading slowly. Each place a different wound, each silence its own kind of specific. In the southern Carpathians, 0 wild individuals remained. The grasslands they once maintained began reverting inside a single human lifetime. Across Białowieża Forest in Poland, just 12 animals survived in captivity, a bottleneck so narrow it still registers in today's immune profiles. In the Apuseni Mountains of western Romania, reintroduction attempts stalled for over a decade. Fewer than 20 individuals were ever present at once, too few to generate the pressure that restructures soil. Along the Redizat Plateau, monitoring transects recorded fewer than 4 large herbivore dung events per hectare each year, so low that the dung beetle community had reorganized itself entirely around absence. Fewer than 4 dung events per hectare annually. That number rewired an entire insect community. The beetles did not die. They adapted to nothing, which is its own kind of ecological collapse written in wings instead of bones. Rewilding Europe's lead ecologist for the southern Carpathians pulled the pre-reintroduction soil compaction data and found something that stopped her. Water infiltration rates in ungrazed plots had dropped to less than 1/3 of what a functioning rooted grassland requires to cycle moisture. 1/3. That is not a struggling landscape. That is a slow drought assembling itself beneath a hillside that looks from any road perfectly green. The surface lies, the roots know, the fungal networks underneath, the threads that trees use to move water and exchange nutrients across dozens of meters were thinning in the dark. No grazer meant no disturbance. No disturbance meant thatch. Thatch meant darkness. Darkness meant collapse, 1 millimeter at a time, invisible from above. Rewilding Europe's field coordinator on the Tsarku project had documented the first confirmed calf born on Romanian mountain soil in over a century. Recorded in Tsarku Field Notes, 2014, she had expected 2 to 3 breeding seasons before recruitment. The calf arrived in the first. She crossed out her original timeline and started the pages again. That calf was not a surprise. It was a correction. The species had not forgotten what to do. It had simply been prevented from doing it for 87 years. And what it does, it turns out, is far more than graze. In the next part, we follow what 170 returning bodies actually changed, measurement by measurement, in the structure of a grassland that had quietly been dying on its feet. The invoices existed before the animals did. For years, land managers ran mowing schedules across the Tsarku range, machinery moving in seasonal rotations, crews contracted out of 3 administrative regions, equipment depots stocked and restocked each spring. The grassland looked managed. From a vehicle on the access road, you would have called it tidy. But tidy is not the same as alive, and the soil underneath those clipped stems kept its own account. Multiple EU funding cycles paid for that maintenance across successive budget rounds. The measurable return, Forbes species richness, held roughly flat. Soil carbon density did not rise. Water infiltration rates did not improve. The fungal networks beneath the surface stayed suppressed, quiet, unrecruited, idle. Then, Rewilding Europe's team opened the release gate. Within 2 seasons, the returning herd had driven more physical soil disturbance across a wider elevation gradient than years of mechanical intervention had approached. Not because the animals were managed, because they were not. The institutional resistance arrived in writing. A regional agricultural authority formally objected, citing bulls reaching 900 kilograms in body mass, fencing infrastructure liability, and compressed access roads as grounds to delay the release. Those concerns were not wrong. A field monitor recorded 6 separate fence breaches in the first autumn alone. bark was stripped from orchard-edge trees within a kilometer of the release boundary. The restoration team documented every incident and did not minimize a single one. Rewilding Europe's field coordinator on the Tsarku project had already learned something about premature certainty. She had crossed out her breeding timeline once before. She did not treat the authorities' damage projections as enemies. She treated them as a separate column in the same ledger. Within the first year, an independent economic valuation placed the carbon sequestration already generated by the herd above the authorities' projected infrastructure damage cost, a figure that institution had never modeled. The herd had not waited for the paperwork to catch up. 54,000 tons of CO2 captured annually. That is what the independent analysis attributed to the herd's reshaping of the Tsarku range. Every fence those animals pushed over was standing in the way of that number. Here's the part no authority modeled. The herd is still growing. 170 animals reshaped a mountain's soil chemistry within 2 seasons. The question the next season's data will have to answer is what a larger herd moving across a wider range will do to the numbers that are not yet in any report. A European bison bull weighs 900 kilograms. Its hooves are the width of a dinner plate. When it steps onto a senescent grass sward, the thatch mat breaks open and a small depression forms beneath the print. That depression holds rainwater for up to 72 hours after a storm. 1 footfall does that. Now put 170 animals moving across a slope through an entire grazing season, and you have produced thousands of micro-catchments that never existed in the managed cutting years. Each one of those micro-catchments is a site where moisture penetrates deeper than the old thatch ever allowed. Roots follow moisture downward, and roots that grow longer die back at a higher rate, depositing organic carbon below the frost line, where it cannot re-enter the atmosphere. Rewilding Europe's monitoring team pulled cores from grazed plots and ungrazed control plots at the end of the first full season. At 30 centimeters, the grazed soil was already measurably darker and denser than the control. The thatch had thinned, the structure had deepened. Then the dung arrived. A single bison deposits roughly 15 kilograms of dung each day. Dung beetles reach those deposits inside 72 hours of the first confirmed excretion events in the Tsarku zone, faster than any researcher on site had modeled for colonization at that elevation. Those beetles did not just consume the dung, they tunneled it vertically into the ground, driving nitrogen deep into the soil column. The forb germination response showed in plant surveys within the first growing season after reintroduction. It was not slow, it was immediate. Rewilding Europe's field coordinator on the Tsarku project, the same person who crossed out her original breeding timeline in 2014 after the first calf arrived a full season ahead of schedule, documented this cascade in sequence, forb diversity rising, pollinators following, insectivorous birds arriving behind the pollinators, and raptors appearing above them. Each link in that chain was measured. None of it was assumed. The monitoring team did not predict a raptor response. They recorded one, and the recording began inside the first growing season, not a decade later. The 2024 independent analysis compared sequestration in grazed Tsarku plots against ungrazed reference land in the same elevation band. The ungrazed reference showed no meaningful gain. The grazed zone showed 54,000 extra tons of CO2 locked in annually. That differential did not come from a model. It came from the ground. Nobody engineered this sequence. A 900-kilogram animal walked a hillside. Its weight, its waste, and its movement did the rest. Because a system that had all its parts in place once before simply resumed the work it had always known how to do. The part no report has yet modeled is what happens when this population doubles. Rewilding Europe's field coordinator on the Tsarku project had learned by 2014 to treat her own projections with suspicion. A bull had already overtaken her breeding timeline before the ink dried. What came next overtook the map itself. The original dispersal models assumed a herd that would consolidate inside the release zone, cautious, trackable, contained. Animals were expected to hold to core habitat for multiple seasons before testing the margins. They did not wait. She documented a bull moving through a forest corridor beyond the designated release boundary, crossing a secondary road and entering private agricultural land no stakeholder agreement had ever named. This was not a failure. It was the animal correcting the model with its own feet. No pre-release habitat suitability assessment had classified that corridor as anything but marginal. The bull disagreed. The friction was real, and the monitoring team recorded it without softening the numbers. On fruit trees, one landowner documented a 900-kilogram animal sheltering in an outbuilding during a storm. The road authority flagged collision risk on 2 road segments nobody had included in the project's infrastructure register. You do not return a wild animal to a working landscape and expect it to behave like managed livestock. The team knew that going in. What they had not fully modeled was what the dispersal would leave behind. When analysts ran the pressure maps against the carbon accounting, the unauthorized range extension had seeded grazing impact, and therefore carbon drawdown potential. Across land, the project had never claimed. The herd was doing more ecological work than any budget line had anticipated. Recruitment rates across the expanding range had already pushed the population beyond the conservative growth curve the pre-release models projected. The animals were finding habitat the models had dismissed, and that habitat was responding. The model was built by humans. No human had ever lived inside a functioning Carpathian bison range long enough to know what one actually looks like. The animal carried that knowledge in its movement, its range selection, its pressure on the land. The model never had a chance. What happens to those 3 farms, those 2 road segments, and the landowner who woke to find a ton of wild Europe standing in his barn? That negotiation is not finished, and the herd will not pause while it is resolved. Rewilding Europe's field coordinator said it plainly in a monitoring debrief, and the words have not left me since. She said, "We kept trying to manage the outcome. The outcome did not need managing, it needed the animal." She is the same researcher who crossed out her original breeding timeline in 2014, the season the first calf arrived on Romanian mountain soil in over a century. She had projected 2 to 3 seasons before natural recruitment. The biology did not consult her schedule. That gap between what we projected and what arrived is the most important measurement in this whole story. Not a failure, a correction. The gap told us exactly how much we had underestimated the animal we were returning. The 170 animals now grazing roughly 20 square miles of Tsarku are not passengers in a managed reserve. A 2024 analysis put their annual contribution at 54,000 extra tons of CO2 drawn into the ground. Through hooves, through grazing pressure, through the slow physics of grassland restored to use. Nobody paid the bison to do that work. Nobody scheduled it. You remove the pressure, you return the missing part, and the system resumes a function it held for 10,000 years before we interrupted it. Reforestation crews working degraded Carpathian slopes spent over a decade attempting to replicate what grazing pressure does naturally, and delivered a fraction of the soil carbon retention that a functioning megafauna population produces. The mountain did not forgive us. It simply resumed the moment we returned what we had taken from it. Biology does not hold grudges. It holds equilibrium. The Tsarku slopes are proof of that. Measured, documented, filed. Share this with someone who still believes the damage is permanent, because the evidence says otherwise. Drop your region and one species you have personally watched disappear from your area in your lifetime. And yes or no in the comments. Have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Next, wolves returned to the Iberian Peninsula's Douro Valley, and within 7 years, the deer populations they began controlling had allowed riverbank vegetation to recover across more than 40 kilometers of degraded riparian corridor. The Spanish federal government, as late as 2021, classified that recovery as incompatible with livestock agriculture across 6 provinces and moved to authorize lethal control. The wolves are doing measurable, unbudgeted ecological work in a landscape that has not yet decided whether it wants them. I'm Dr. Raymond Finch. I'll see you in the field.